Hello again. This is Math 2233 coming to you from the College of DuPage. The title of this lecture is More 3D Surfaces, Cylinders and Quadrics. And as always, I encourage you to be an active learner while you watch this video. We've already looked at two spatial types of surfaces, planes and spheres. And here we investigate two other types of surfaces, cylinders and quadric surfaces. Now, in order to sketch the graph of a surface, it is useful to determine the curves of intersection of the surface with planes parallel to the coordinate planes. These are called traces or cross-sections of the surface. Now, by way of introduction, these are very important. For example, when a doctor reads the results of a magnetic resonance imaging scan by looking at cross-sections of the scanner's results, these cross-sections are intersection of the scanner's plane and the object being scanned, like your head. When choosing a barrel, a brewer must consider its volume. Wooden barrels are often shaped like ellipsoids with two ends removed. Intersection of planes with such an ellipsoid give cross-sections that can be used to approximate the barrel's volume. And many transmissions are sent using satellite dishes. A common design of a satellite dish uses the shape of a paraboloid. Intersection of planes with this shape gives circles in one direction and parabolas in the other direction. A cylinder is a surface that consists of all lines that are called rulings that are parallel to a given line and pass through a given plane curve. Now, that's a definition, but it's much better to look at an example. So here, the first example, you're being asked to sketch the graph of the surface z equal x squared. You know what to do. Let's see how you did. Well, the equation z equals x squared does not contain y. So that means, the vertical traces of this are just parabolas that look like, and here we're letting y to be 0. And so if y was 0, what you're going to get is z equals x squared, which is going to look like that. Now, if you go away from that for y equal k, it's going to intersect the curve in still a parabola, but y is going to be something else as we go along. So you see I get all these parabolas. Here's for y equal 3, y equal 2, y equal 1, and there's y equal 0. This is y equal minus 1, y equal minus 2, y equal minus 3. And then, since this is three-dimensional, there's an infinite number of these, so I have to think about putting wallpaper around the wire outline that I have. And this is the three-dimensional surface that we have. So we connect the infinite number of the vertical traces to get this. Now here, the rulings are parallel to the y-axis. So those are the rulings, and these are the rulings that they're showing right here. And you see those are lines that are parallel to the y-axis. Now notice that the variable y was missing, and that's what made it a three-dimensional thing. We knew it was a three-dimensional thing because it was a surface. So that was typical of a surface whose rulings are parallel to the coordinate axes. If one of the variables x, y, or z is missing from the equation of a surface, then the surface is what we call a cylinder. And so here we're supposed to identify and sketch these surfaces. There are two, A and B. You want to pay attention to what's missing. You know what to do. Let's see how you did. Okay, since z is missing in the equation, we can pick any plane z equal k, and let's just start with z equals 0. So here's the plane z equals 0 down here, but then x squared plus y squared is a circle of radius 1 in that plane. But if I make z be any number bigger, now realize that z is equal to x squared plus y squared, so it's always bigger than or equal to 0. So I would say 1, 2, 3, and 4. I get these circles, and there are an infinite number of these circles that I go, so it is like wallpaper. So this is the surface. The bottom of the surface is here, but it just keeps on going higher and higher and higher as a cylinder in three-dimensional space. The second one that you were supposed to do, this was y squared plus z squared equals 1. Here the x is missing. So x equal k, and if we let x to be equal to 0, we're right here, so it is a circle. The unit circle in the yz plane of radius 1. But then I can let this x be any positive number, and I get all of these. It can be any number in between, so I put wallpaper on the outside and I get this thing. So the rulings are parallel to the x-axis. Note when you're dealing with surfaces, it's important to recognize that an equation like x squared plus y squared equals 1 represents a cylinder, not a circle. But the trace of x squared plus y squared equal 1 in the xy plane is a circle. But the equation there is going to be x squared plus y squared equals 1 and z equal 0. We're now going to turn our attention from cylinders into quadric surfaces. A quadric surface is a graph of a second-degree equation of 3 variables. This has x, y, and z, not just x and y. And the most general such equation is this one. Now the a, b, c, and all these numbers are constants, but then you have each term is of order 2. So x squared plus y squared plus z squared, those are order 2, but here the exponents add up to 2. And we do get something that it's of 2 or less. So this is order 2, 2, 2, 2, 2, 2, 1, 1, 1, and order 0 is equal to 0. Where a, b, c, and all the way up to j are constants. But by translation and rotation, it can be brought to any one of 2 standard forms. And we did this in your calculus too, but either it's going to look like ax squared plus by squared plus cz squared plus j equals 0, or it's going to look like ax squared plus by squared plus iz is equal to 0. Now, these quadric surfaces in 3 dimensions are counterparts of the 3-dimensional conic sections that you studied in the plane. And quadric surfaces are also important. For example, when designing flashlights, engineers use approximate shape of an elliptic paraboloid for the flashlight's reflector. This allows the light to be focused in a narrow beam forward from the bulb. Also, architects make use of hyperbolic paraboloids to build a saddle roof. And so you're seeing the roof here. It looks a little bit like a saddle. And this design is used because it's easily constructed from straight beams of material. And astronomers often consider the shapes of stars and planets. Planets and stars are commonly modeled using shapes of ellipsoids. This model allows for simpler mapping methods that retain much accuracy. And nuclear power plants also use these for their reactor exhausts, and these are very structurally sound this way. And we'll see that this is a hyperboloid. Okay, so now what we're doing is we're trying to look at using traces to sketch this quadric surface. So here we have x squared plus y squared over 9 plus z squared over 4 equal 1. You know what to do. Well, let's see how you did. So this is the equation that we have, but if we let z equal k, then you see z is equal to k. That means we have x squared plus y squared equals 1 minus k squared over 4. Now, since this is x squared plus y squared over 9, that has to be positive. So k is between plus or minus 2. But you see these are going to be various kinds of ellipses that we'll have. So when when k is equal to a smaller number, you get things below the axis, then you get this, it becomes the biggest, then it gets smaller, and then it gets smaller still. So that is what is happening whenever you look at z equal k. If we let y equal k, we get x squared plus z squared. These are also ellipses, but these ellipses are not in in these direction. These ellipses are in this direction. They're in the x z plane, and then you can move it out and back. And here k is going to run from minus 3 to plus 3, and that's if k is bigger than 0, you get these in the whenever we're looking in the x equal k plane. So we looked at y equal k, x equal k, and we get all of these ellipses. There's ellipses every way. If you take them together, you get this as the graph. And notice that we do know what these endpoints are by our calculation. Okay, so now I'm going to ask you to use traces to sketch the surface z equal x squared, 4x squared plus y squared. And realize here that z is the sum of these numbers, but now there's no constant. Okay, so you know what to do. And we'll see how you do when we turn to the continuation of this video. But for now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other. Till the next video, God bless you.